Okay, in Chapter 9, we're introducing what's called the t-statistic. The t-statistic is similar to a z-score, but this is for the sample means. So we're going to base our hypothesis tests and confidence intervals on this. And again, this is specifically for a mean. So the proportions relied on z values and z-scores and z-statistics, and the means are going to rely on the t-statistics. So if the conditions for the CLT hold, the t-statistic will follow the t-distribution. The t-distribution is symmetric, it is unimodal, and it is bell-shaped. The difference between it and the z, or the normal distribution, is that it has thicker tails. So it is slightly different. And it's more likely that we will see extreme values far from zero than in the normal distribution. So you can kind of see them compared one-on-one in this image. The z distribution is, again, for proportions. And the t distribution we use for means. So they both have that symmetric unimodal quality. They both follow then the empirical rule, percentages, and we'll be able to use that normal calculator on both of them, even though they're slightly different. Okay, let's see. Last example in 9.2. We've got the mean age, so just practice picking out those key words. The mean age of all 2,550 students at a small college is 22.8 years with a standard deviation of 3.2 years. The distribution is right skewed. That's going to be important. A random sample of 50 students is obtained. The mean of that sample is 23.2 and a standard deviation of 2.4. So first, we want to just practice again with our notations and with our symbols. We've got mu, sigma, x bar, and s, and we just want to say which of these things is which. Okay, my Greek symbols are the ones that go along with my population. These are the ones that are sometimes unknown and that we're trying to estimate. This college is small enough that they're actually able to get this information about ages from every single one of them. The mean is 22.8 and the standard deviation is 3.2. And then these come from our sample, the standard English letters. So that would be the mean of 23.2, standard deviation of 2.4. Which of those are parameters and which are statistics? Well, keep in mind the first letter helps you with those. Parameters are from your population, so that's these. And statistics are from your sample, which are these. Are the conditions for the CLT fulfilled? And what would be the shape of the approximate sampling distribution of many means, each from a sample of 50 students? So here I would say yes, the conditions for the CLT are met because the sample was large enough. That's the only one we really have to check. So because we meet the CLT, what will this sampling distribution of means look like? It should tend to look like a normal distribution. Will it be perfect? Maybe not, considering the first one was right skewed, but it should tend to be pretty close at that point. What if the random sample only contained 5 students? What would the shape of the sampling distribution be? Okay, so the CLT would not be met here, right? Because 5 is not bigger than 25. So when the CLT is not met, we cannot say that this is going to look normal enough to look like the calculator. It probably still looks right skewed. So it's probably still at least somewhat right skewed.